My name is Tom O'Neill. I am the CTO and co-founder at Periscope Data. Let's get started. So at Periscope Data, we aspire to build the fastest, most powerful, most flexible BI platform. And that is the entire sort of life cycle from ingestion and storage through to modeling and analysis out to visualization and sharing. We have over 1,000 customers, including New Relic and Uber and Flexport. The average analyst spends about 20 hours per week in the product. Like, this is a product you live within and push a lot of data around. And with some math, you can see that the average customer has 4 or 5 databases connected to the platform. And that's because a big part of the value we bring is helping customers warehouse that data and analyze it at scale. And through doing that about 1,000 times, we've learned some things. I'm going to share a little bit about that with you today. So there's two big themes to this presentation. We're going to talk about the back end when it comes to column versus row-based stores, and the front end when it comes to your schema. And when I refer to warehouses, I refer to how the technology is being used, not what it was designed for. And so Redshift is a warehouse. Postgres can be a warehouse. Presto can be a warehouse. It's all how you use it in your analytics stack. So we'll do the first one first. So in the beginning, Ralph Kimball invented what we now know as dimensional modeling. This is the star or snowflake schema designed for analysis. This happened during a time when the only databases available were row stores. And so the technology involved encouraged very narrow tables with lots of joins and lots of foreign keys, which pushed a lot of the complexity of the analysis toward the front end to the end user queries. And understanding why that is important to understand the trade-offs between row-based and column-based stores. So in a row-based store, the table's data is effectively stored as a CSV, right? And you use indices to jump to the right line in the CSV, and you can read it sequentially from disk in order to get just the row you want. This is why web servers are backed by things like Postgres and MySQL, because if you want to show a user their profile, like select star from users where ID equals 10, seek to disk, read it, you have all the columns you need for that user. Row databases, however, are terrible for analytics in general, right? If you want to sum just one column in a CSV, you have to read the entire CSV. There's not a way to skip and read just that column. And that's why Kimball invented these very narrow, very simple tables that have a couple foreign keys and like 1 fact or 2 facts. Because if you have to read the whole table for analytics anyway, you might as well rely on indices, rely on joins, and have very low I/O for a narrow table. This worked well in the 80s and early 90s when most of the BI work was around sales and marketing data, and you could model everything. Up until that point, we had been doing sales and marketing for centuries, if not millennia, and so all the questions you'd want to ask about your data were known. You want to segment revenue by geo by rep? No problem, build a model for that, works great. But recently, the amount of data sort of in the ecosystem has exploded, and that's because storage became free. If you look at your AWS bill, in most implementations, S3 is noise compared to everything else. And because storage is free, people started storing everything, right? It's IoT sensor data from planes and ships around the world. It's real-time text message data. You instrument every part of your product or game and just store it all, right? Just store everything. You'll figure out how to analyze it later. This broke sort of the Kimball model because row stores don't scale in this direction. And so for a hot minute, Hadoop sort of took over in the analytics space. Right? OK, we'll use MapReduce. It scales horizontally, unlike most row stores. And this worked great, except it was too hard. Right? If you want to sum your transactions table and segment by something, you're writing a program to do that. And there were some SQL layers for it, but it was just too much work to write a program for every analysis. And that's why MPP warehouses like Redshift took over. You get the same interface as a row store, but it acts much better for analytics. So the row stores sort of changed the rules. Now that storage is free and you could scale horizontally, you no longer had to use narrow tables, and you no longer had to worry about just being able to vertically scale your server. The flip side is these horizontally scaled databases, these clusters, they don't have indices and they don't have joins. And so the things you would typically rely on for having a highly dimensionalized schema start breaking down. And if you try joining 1 billion row table to another, you're going to have problems. And so this new world encourages very wide tables. And columnar data stores, column-based data stores, are designed for super wide tables. So instead of in a CSV where data is stored sequentially by row, in column-based stores, data is stored sequentially by column. So it's possible to have a users table with 200 columns and only read out the columns you care about because the column data is sequential. This encourages wide tables. This encourages baking more of your business logic into the ETL as opposed to in the analytics layer with a semantic web or semantic net. So if you think about these two tables sort of next to each other, these types of data stores, they're both useful, right? You want row stores for very low transaction time, very low data volume sort of serving of queries. Think filters, think drill downs. And you want column stores for the heavy lifting. This is where you do your modeling. This is where you do your heavy analysis over billions of rows of data. At Periscope, we use both, right? This is a typical workflow, highly simplified, that we help customers with. We can ingest from just about any source, where the origin data might be in a lake in S3. It might be in other databases like Postgres or MySQL. It might be in SaaS products like Salesforce. We pull that into our lake in S3, and then load that data into Redshift primarily, do all the transforms, all the cleaning, all the manipulation, and then push subsets of that data into Aurora Postgres. And then depending on the user's needs and the use case of the dashboard, you might point it at the column store. If it's heavy lifting, you might point it at the row store, if it's highly transactional and very fast. Aurora Postgres and Redshift are actually really good friends to use together because they both use dialects of Postgres. And so you don't have to rewrite most of your queries to run on both of those technologies. So this is the sort of the back end. OK, we've got a warehouse. We've chosen which one we want. For now, let's talk about the schema. There are a lot of decisions to make when it comes to your schema. Most of them are tabs versus spaces. Like, doesn't really matter which one it is as long as everyone does the same thing. If you're inconsistent with your schema today, your future self will hate you. So figure out the choices you want to make, that your team want to make, and do that, and push that forward sort of in your analysis. So some things we recommend to customers who are working on their schemas is to build them in layers, right? The first layer, the most base layer, is to put a buffer between your queries and the origin tables in your warehouse. Right? If you query tables directly, you're stuck with that schema. And as data teams, we generally don't control the schemas that we are given. We inherit the schema from the engineering team. We are given a schema by Salesforce. We don't control these things, and they do change from time to time. And so put a bunch of select star views in front of all your tables and query those. It'll save you later. For example, a few months ago, we switched one of our internal ETL vendors for our data team. They went from one vendor used camel case, the other vendor used snake case. In a previous life, this would have been weeks of work to rebuild and rewrite thousands of dashboards and queries. But because we had this protective layer, you can just change it to be, instead of select star, you can select aliases of all the columns, and everything else works fine down the chain. So the staging tables is where you start doing real work. These are the closest you get to Kimball in a Columnar store. They are very simple. They are single concern tables. These are unit testable. And so this is where you unroll polymorphic joins. This is where you deal with how do you connect a customer to a user, because sometimes it gets complicated. And so once you've built up a whole layer of unit-tested staging tables, then you can join them together into reporting tables. And this is where the fun happens, right? This is where most of your charts will be doing their analysis. This is where you build those 200-column-wide customer table, users table, et cetera. And lastly, if you're at scale and you need to build a collection of reporting tables for a certain business unit, we call those data marts. We're sort of team-focused, and this naturally, the joins are natural here, and you don't need a semantic layer to help you figure out all those joins. We're going to zoom into the graphic on the right. This is a dependency diagram for one of our dashboards at Periscope Data. At the very bottom in purple are charts. And you can see what those charts depend on. Most of them depend on reporting tables in yellow. Some of them also depend on sort of staging tables in green. You see the reporting tables are much longer than the staging tables, are much wider. And in the blue is a protective layer. And so this is to show you, in the real world, you don't need to be dogmatic about everything has to only pull from a reporting table, because sometimes it's not practical or useful to push all data forward to reporting layers. It's OK to pierce the veil and go down to a staging table or a protective view. We had another sort of issue like the ETL one, where in Salesforce, we changed how we were recording dates to go from PSD to UTC. And again, we just changed a few things in the protective layer, and that helped us sort of save a bunch of effort instead of having to redo a bunch of charts that assumed time zones. So now let's talk about syntax. Right? This is where you start getting into sort of style guides for your SQL. This is where you want the whole team to be working on the same sort of style for their SQL. If you think about Boolean columns, do you want them to be Hungarian cased with a B underscore paying, or maybe you use more English, Ruby style, which is like is paying. But as long as you do the same thing, everyone will understand it in the future, and as you onboard new members to your data team, they'll be able to figure out the schema no matter what table they're in. I think perhaps the most important one on this slide is the last one, limiting the complexity of queries. Because if you take a look at the two queries on the right, they do the same thing. They're both calculating monthly recurring revenue for a SaaS product. And they both have the same bug. Right? In these queries, if a customer joins and churns within the same month, the churn will be noted in the month after, not the current month, which is a problem because data about money has to be right. And so if you look at these and you try to figure out how to fix them, like the first query is a train wreck, right? There's at least 3 levels of nested selects. There might be a select buried in some where clause. Like, good luck fixing that and not introducing a new bug. But the second query, like this is beautiful. This is the kind of query you want, and because it's a glorified group and count, which is most of analytics, and it relies on a reporting table called business metrics, which relies on staging tables called other things, and you can just fix this churn bug in either the staging table or reporting table, depending on where it makes sense, and that'll propagate through to all the charts that depend on the schema, sort of saving this chart and all the bunch of charts a lot of errors. And lastly, in terms of schema, you'll have lots of kinds of tables. Right? You'll have roll-ups, you'll have archives, you'll have dailies, you'll have totals. We use all these kinds and more, but it's really important to be consistent with how you use them. Right? If you have an archive table, like all archive tables should probably have archived at, right? And the same column name for what was the original primary key of the table it's archiving from. This way, as new folks on your team join, they want to onboard, they can figure out where these tables go and how they work without having to read giant sets of documentation. So looking back at the sort of the 2 things we talked about so far, like you're going to want a hybrid warehouse model, right? You need column stores for most things, row stores for certain kinds of serving, lakes for volumes at scale, especially if it's unstructured and messy data. And then the schema is the UX of your analytics product, right? The back end is technology, the front end is the schema. You really want to focus on a good, solid schema so that more folks on your team can scale up to it as you grow. And as a closing thought, like why does this matter, right? At Periscope, we think about data teams along a maturity curve, right? Everybody starts on the far left, which is just basic business reporting. This is where you get your Salesforce reports. This is your marketer reports. How is sales doing? How is marketing doing? You can tell it from a single product. But at some point, you graduate to BI, and you want to know how are marketing leads impacting product usage, right? Which customers came in from which channel? And that's where sort of basic BI comes into the play, where you can join data across different data sources. But that's not enough, and a lot of data teams get stuck there as part of a ceiling. And that ceiling is partially based on not having the right tech or the right schema to help you scale. And so you want to get to the point where you can do ad hoc analysis, you can answer questions you didn't have yesterday, right? A port closed in China and shipping routes are changed. How do you decide what to do about your business, right? You can't remodel it and wait a week for the database to catch up. Like, you have to do it now, right? So you want that sophistication on your team. And then your data team's org chart will change, right? It'll start as 1 or 2 folks. Then it becomes, maybe it rolls up to the CTO or rolls up to the marketing. But at some point, you want to have a centralized data org, and you want to have certain people in that org sort of dotted line out to various business units. So you can analysts specialize in marketing or analysts specialize in sales, but they still belong to a whole. This only works if you have the right technology and schema choices that let your team scale, because you simply can't take the time to teach every analyst to be an expert in every part of the ecosystem. And lastly, on the far right, like, this is where we're aspiring to go. Right? Data in its very nature is historical, it's backwards looking, it came from something that already happened. But in order to drive our businesses forward, we need to use data strategically. Right? You want to operate the business at scale with data, not just how much money will we make next month, but what will happen to the business next quarter, next year, and how do we push that with data. And that only happens if you have the right foundation. So hybrid warehouse, super strict schema, and the rest is easy. So that's me. I'm Tom at Periscope. We are hiring all the things. If you want to join my team and help build the fastest, most powerful, most flexible BI platform, please drop me an email, and I'm happy to take questions now or after the event. Okay. So the question was...
the question is, can you speak to that more? Because I was a little bit confused on, like, oh, it's just tabs versus spaces?
Yeah, so the question was, when you're designing your schema, some decisions sound like tabs versus spaces and some don't. The tabs versus spaces comment was specifically to refer to decisions that seem like bike shedding, right? It doesn't always matter what you name certain columns. Is it created at or created date, as long as it's consistent. But you're absolutely right that depending on the technology you're using, you will want to build your schema differently, right? In a row store, you'll expect to have a lot more foreign keys, a lot more joins, because it's good at that. It can be indexed. If you want, you can index every column. But in a column store, when you can't use indices and joins, you might name things differently because there's fewer foreign keys.
So I looked at your previous presentations, and you guys compared like Redshift and Snowflake a few years back. How do you compare now between Redshift and Snowflake for your backend database?
Sure. So the question at an AWS conference was, how do we compare Snowflake and Redshift? They are they are good at different things. Redshift has certain characteristics that make it really, really great for types of data that don't require high query concurrency, right? Snowflake has features around query concurrency that make it very good for that type of scale out. It's really important to try both because they have different strengths and weaknesses, and data sets vary quite a lot. They're both self-sign-up, they're both easy to get to, so figure out what the right one is for you. Periscope, of course, supports both.
All righty. Thanks, Tom.
Thank you.